I welcome you all for the session 7 on interference of light. Interference fringes produced by wedge shaped film. Learning objectives is to know interference fringes produced by wedge shaped film and constructive and destructive interference produced. Prerequisites for the session: one should understand about the interference of light, Young's double slit experiment, constructive and destructive interference. Okay, fringes produced by wedge shaped film. Consider two optically flat similar glass plates in contact at one end using a rubber band and inclined to the other at an angle theta using a blade or wire kept in between the glass plates at the other end. If the liquid drop of a refractive index mu is kept between the plates, then it encloses liquid film of the variable thickness with zero thickness at the end and the thickness equal to the thickness of the object kept at the other end as shown in the figure. Let the film is illuminated by monochromatic light from a slit arranged parallel to the edge of the wedge. Interference occurs between the rays reflected at the upper and lower surfaces of the film respectively, and parallel interference bands results. These bands are alternately dark and bright. Let small t is the thickness of the film at a distance x from the edge. The geometric path difference between the two rays at this point is given by delta is equal to 2 into mu into t into cos r, which is equal to 2 into mu into t, because r is approximately equal to 0 and cos r is equal to 1. Since the angle of a wedge theta is very small, we can write t is equal to x into t. Therefore, the path difference is equal to delta is equal to 2 into mu into x into theta. Therefore, condition for bright fringe. At the position x, nth dark fringe is formed when the following condition is satisfied: 2 into mu into x theta is equal to n plus 1 by 2 times lambda. The distance of the nth bright maximum is x1 is equal to n plus 1 by 2 into lambda by 2 into mu into theta. Similarly, condition for dark fringe. At the position x, nth dark fringe is formed when the following condition is satisfied: 2 into mu into x into theta is equal to n lambda. The distance of the nth bright maximum is equal x1 is equal to n lambda divided by 2 mu theta. Then fringe width. If x1 is the distance of the nth dark band and x2 is the distance of the n plus mth dark band, then x1 is equal to n lambda divided by 2 mu theta and x2 is equal to n plus m into lambda by 2 into mu into theta. Therefore, the width of the m fringe is given by x2 minus x1. Therefore, x2 is equal to n plus m into lambda by 2 mu theta minus x1 is n lambda by 2 mu theta. If you simplify, then you will get a m lambda divided by 2 mu theta. Therefore, the fringe width beta is equal to x2 minus x1 divided by m, which is equal to lambda by 2 mu theta. If d is the thickness of the object used to form the wedge shaped film and small l is the length of the air wedge, then theta is equal to d by l, or l by theta is equal to 1 by theta is equal to l by d. Therefore, beta is equal to lambda l divided by 2 mu d, or small d is equal to lambda l divided by 2 mu into beta. Thus, by finding beta experimentally and by knowing lambda, mu and l, the thickness of the object to form the wedge shaped film can be calculated. By finding small d using a screw gauge and by knowing a lambda and l, the refractive index of the liquid used as a wedge shaped film can be calculated. Also, by finding small d and knowing mu and l, the wavelength lambda of the monochromatic source can be calculated. Okay. Okay, let us see some of the questions on this session. The question number 1, interference occurs between the rays dash at the upper and lower surfaces of the film respectively, and parallel interference bands results. Option A, reflected. Option B, refracted. Option C, both A and B. Option D, none of the above. Therefore, answer for this question is option A, because the interference occurs between the rays reflected at the upper and lower surfaces of the film respectively, and parallel interference bands results. Therefore, answer is option A. Thank you for patient listening.